Good morning. Myself is Dr. M.MADHIARASAN, Assistant Professor, Department of Electrical and Electronics Engineering, Bharat Institute of Engineering and Technology. So today we are discussing about induction motor speed control system. So previous class we have discussed about that is speed control mechanism of DC motors. The DC motor speed can be controlled with the help of converters, that is rectifiers, and with the help of choppers. So with the help of choppers and the rectifiers we can control the firing angle to achieve the speed control mechanism of DC motor. So today we have to discuss about the induction motor speed control system. So induction motors that is nowadays are commonly used for variable speed drive application. But in earlier days, the induction motors is only applicable for the constant speed drive application. Why? Because so at the time the power electronic devices was not inverted. So after the invention of the power electronic devices, the induction motors are used for the variable speed drive application. So before the advent of the power electronic devices, the induction motors only suitable for the constant speed drive application. So we can't use the induction motors for the variable speed drive application. So the variable speed drive applications are performed with the help of DC drives, that is DC motors. Why? Because the DC motors having excellent variable speed drive characteristics. So that's why the DC motors are chosen for the variable speed drive application. But after the advent of power electronic devices, the induction motors are now recently used for variable speed drive application. So with the help of converters, that is voltage source inverters, current source inverters, cycloconverters, we will achieve the variable frequency as well as variable voltage. So once my variable frequency and variable voltage is achieved, we can control the motion of the induction motor. So previously the DC motors only used for the variable speed drive applications, but after advent of the power electronic devices, induction motor also nowadays most of the places replaced the DC motors with induction motors. Why? Because the induction motor speed control with the help of converters will be cost effective and it will achieve the improved efficiency. So the compared to the DC motor, induction motor is rugged in construction and we can't require any maintenance and we can use the induction motor for any type of environment such as the explosive, because in induction motors there is no concept of sparking, but in DC motors we are suffered because of the sparking problem. So due to the commutators, so we are having some sparking problem. So in order to overcome the limitations of the DC motors, so induction motors nowadays used for many industrial applications. So whenever we are talking about the induction motors, the main concept is drive mechanism. A drive is nothing but a system employed for motion control is known as a drive. So the motion of the induction motor is controlled with the help of voltage source inverters, current source inverters, or cycloconverters, or AC voltage controllers. So with the help of these type of power electronic devices, we can control the induction motor motion. So today we are discussed about the complete stator side control methodology and rotor side control methodology of induction motor. So induction motor speed can be controlled with the help of two side of control methodology. So one is by controlling the stator side parameters, we can control the motion of the induction motor. So next methodology is by controlling the rotor side parameters, we can achieve the speed control mechanism of induction motor. Induction motor advantages is it is rugged construction and it is less maintenance is required, and induction motors is suitable for low to the high power application. And one more advantage is the induction motors is used for explosive environment also. So with the help of the drive systems, So we can control the motion of the induction motor. So previously the induction motor used for constant speed drive applications. So with the help of power electronic devices, nowadays industries are concentrating on induction motor for variable speed application because of the less cost and high efficiency. So, we know about the induction motors classified into two types. So, one is squirrel cage induction motor and next type is slip ring induction motor. So, most of the industries are preferred only the squirrel cage induction motor because the squirrel cage induction motor is very cheap and rugged in construction and with having the less maintenance. So because of these features, the squirrel cage induction motor is preferred over the slip ring induction motor. The slip ring induction motors, so by controlling the rotor side, we can control the slip ring induction motor. So the induction motor can be classified into two types. So one is squirrel cage induction motor. Second one is slip ring induction motor. So, the induction motor speed can be controlled with the help of two type of control methodology. So, one is control methodology of induction motor. So, by controlling the stator side parameters, we can control the speed of the induction motor. So, that type of control is known as a stator side control. So, second methodology is rotor side control. So, by controlling the rotor side parameters, we can control the induction motor speed. So again, the stator side control methodologies are classified into four types. So first methodology is stator voltage control methodology. Second one is variable frequency control methodology. And third type is V by F ratio control method. Fourth type is changing the number of poles. So, by changing the stator side voltage as well as current, we can control the speed of the induction motor. So, by varying the frequency of the induction motor, we can control the speed of the induction motor. So, third methodology is by making the V by F ratio as a constant, we can control the speed of the induction motor. And fourth one is by changing the number of poles also, we can control the speed of the induction motor. So, all these parameters are stator side parameters. So, by controlling the stator side parameters, we can achieve the speed control mechanism of induction motor. So, that's why this type of control method is known as a stator side control methodology. So, by varying these parameters, we can achieve the motion control of induction motor. So next methodology is rotor side control methodology. So again, the rotor side control methodology can be classified into two types. The first type is static rotor resistance control. The second type is injecting the EMF into the rotor circuit. So we know that the stator side control methodology is applicable for squirrel cage induction motors as well as slip ring induction motors. But whenever we are talking about the rotor side control methodology, the rotor side control methodology is only applicable for the slip ring induction motor. So we can't apply the rotor side control methodology for the squirrel cage induction motor. So the rotor side control methodology is only applicable for the slip ring induction motor. Because in the slip ring induction motor only we can vary the rotor side parameters. In squirrel cage induction motor we can't vary the rotor side parameters. So that's why the rotor side control methodology is only applicable for the slip ring induction motor. So applicable for slip ring induction motor. So today we discussed about what are the control methodologies available for induction motor. So in induction motor the speed can be controlled with the help of rotor side parameters and the stator side parameters. So by controlling the stator side parameters such as stator voltage control and variable frequency and V by F ratio and changing the number of poles, we can control the motion of the induction motor. And by regarding to the rotor side parameters, that is adding the external resistance into the rotor circuit, we can achieve the speed control of induction motor, and injecting the EMF into the rotor circuit we can achieve the speed control of induction motor. So these are the schemes available for motion control of induction motor. So I refresh the concept what we discussed earlierly. The induction motors earlier days are used only for the constant speed drive applications. So after the advent of power electronic devices, we can vary the frequency as well as we can vary the stator voltage. So with the help of the power electronic devices, induction motors nowadays used in all type of industrial for variable speed drive application. So before the advent of power electronic devices, the DC motors only used for the variable speed drive application. So after the advent of the power electronic devices, the induction motors also nowadays used for variable speed drive application. Why? Because induction motors having less maintenance and cost effective, high efficiency, and moreover we can use the induction motor for any kind of environment, explosive environment also we can use. There is no problem of sparking with respect to the induction motor. But when we are talking about the DC motors, so there will be a sparking problem. So that's why we can't use the DC motors for any type of environment, because it will create some problem, that is sparking lead to the damaging the windings, and it requires more maintenance and it is costlier. So that's why nowadays the induction motors are most widely used for the variable speed drive applications with the help of power electronic devices. So next methodology is how to control the speed of the induction motor. So whenever talking about the speed control schemes of induction motor, we can control the induction motor speed with the help of two type of strategies. One is by varying the stator side parameters, we can control the speed of the induction motor. So this scheme is known as a stator side control method. Here what we are doing, so by changing the stator side voltage we can control the speed of the induction motor. So by changing the variable frequency, so we can achieve the speed control mechanism of induction motor, and by making the V by F ratio as a constant, we fix the flux as a constant and we can achieve the speed control mechanism of induction motor. And changing the number of poles also we can make the induction motor speed control mechanism. So next methodology is rotor side control scheme. So by adding the external resistance into the rotor circuit, we can achieve the speed control of induction motor. But whenever we are talking about the rotor side control, it is only applicable for the slip ring induction motor. So we can't use the rotor side control methodology for squirrel cage induction motor. Next methodology is injecting the EMF into the rotor circuit. The ultimate aim is by adding the resistance into that rotor circuit, we can achieve the speed control mechanism. Today we have discussed about the induction motor speed control mechanism. So next class we will discuss about the each schemes in detail. Thank you one and all.